HTG System 3A mask aligner. This mask aligner includes a Nikon microscope, the lamp housing that can handle up to 350 watt mercury arc lamp, and the aligner module and a timer module. Currently the system is set up to use a substrate of 4 inches. Even a 3-inch substrate can be mounted here, but due to the contour on the substrate holder, there may be some vacuum losses. The substrate is held under vacuum using this line, and the orange color line here is for the contact vacuum, and the contact is between the surface of the wafer, the top surface of the wafer, and the bottom side of the mask. And the vacuum is generated using this gaskets, the sealing gasket, which is on the edge of this substrate holder, and it gives a proper contact, while the contact vacuum level could also be monitored in the vacuum gauge here and adjusted using this knob. There is also a nitrogen purge which has to be enabled using nitrogen, so that after the exposure, in order to separate the mask and the wafer, the nitrogen should be on. Now this system is fully manual, and a motorized drive mechanism moves the whole lamp housing and microscope to and away from the aligner module, which I'm going to demonstrate. So I have a 5-inch mask here, and the mask is to be installed in such a way that the pattern is on the bottom side of the mask, and then after loading the mask in the groove here, put the mask clamp and tighten it gently using these screws. Certain mask holders are held under vacuum using this mask on-off pneumatic switch, and the mask vacuum is available here. So right now this mask is mechanically held using the screws, but in case when a different mask holder is held using vacuum, this line has to be connected to the new mask holder. So this is a mask holder frame, so I'm mounting it, and there are 3 knobs for moving the stage in X, Y, and Z directions. This is for moving it along the X-axis, and this knob is along the Y-axis, and this knob moves the sample holder up and down. And there is a 4th knob here which rotates the chuck across around a vertical axis, so that gives to align when there is a small angular difference between the mask pattern and the substrate pattern. So in order to load a substrate, the whole mask holder need not be removed every time. Just by using the toggle switch here, pneumatic toggle switch, the frame lifts up and turn off the substrate vacuum, and the substrate can be removed from this area. then lower the mass frame and pressing the cycle button will move the microscope into the alignment area. On the microscope, there is a fiber optic illuminator. Currently, the system is configured with 4 objectives: 5x, 10x, 20, and 40x. And there is a micrometer for fine focus adjustments. And the microscope is pneumatically can be moved up and down. So at the time of alignment, the microscope should be in down position, and when the table needs to be rotated, the microscope should be in up position. Only then the cycle button is emerged. Also, the microscope can be moved on this XY table here by pressing these pneumatic these are switches which turn on 2 solenoid valves to disable the vacuum under the table, so that we can move it along the y-axis and x-axis. Care should be taken not to move it to the extreme ends. Take it off. The lamp housing can be opened by opening the 2 thumb screws on the front side of this gray panel, and there is a ellipsoidal reflector here through which the lamp is installed. I'm going to show how the lamp is to be installed here. It's a 350 watt lamp, and the lamp is to be installed in such a way the anode is in down position. So this gold plating area should be on the down position. So first you identify the anode and hold it at the anode end and screw it in the lamp mounting assembly where the cathode wire is connected. And now there is a heat sink that goes on the lamp anode, and you insert the heat sink and then run the braided wire there and gently tighten the thumb screw. So the lamp is installed, and this is a dichroic reflector which reflects 365 nanometer and around 405 to 400 nanometer wavelength UV rays onto the integrator, which is over here. And behind the integrator there is a shutter, which is an electromagnetic shutter. Electrical signal goes to the operation of the shutter. And there's a cooling fan. The lamp power supply here is normally located under the table area here, but just for demonstration I pulled it out. So this power supply can be operated in constant intensity or constant power mode. When the unit is first powered up, it is recommended to use constant power mode and set the knob in watts, and this meter here on the left indicates current and voltage, And when the lamp is not ignited, the open circuit voltage across the anode and cathode will be about 175 volts DC. And the second meter here, which indicates either power of the lamp in wattage or intensity in milliwatt per centimeter square. There are 4 knobs here down there, the potentiometer knobs, which are useful to calibrate the 2 channels. Channel A is set for 400 nanometer. Channel B is for 365 nanometer wavelength. When we select channel B, initially we use the cal path to calibrate the UV intensity after the lamp is warmed up sufficiently, about 15 to 20 minutes. A UV lamp requires an initial warm-up time of about 15 to 20 minutes. So once the lamp is calibrated with the the UV intensity level, the set knob can be used to operate the lamp using the constant intensity mode around +2 plus or minus 5 milliwatt per centimeter square of UV energy. So right now the lamp just powered up and it's showing about 325 watts. We can adjust in constant power mode. Normally when the unit is in idle mode, it is recommended to leave the lamp idling wattage of about 275 watts. After the lamp is properly warmed up, we can use the test button on the panel to open the shutter and start adjusting the intensity or start to check the constant intensity mode. So right now the intensity level is about 10 milliwatt per centimeter square, and so I'm able to select the constant intensity mode and select a channel B for 365 nanometer, and I'm able to set the intensity level between 15 milliwatt per centimeter square to 20 milliwatt per centimeter square. If we switch to channel A, and then we can set the intensity level to match the desired wattage between 25 milliwatt per centimeter square to 30 milliwatt per centimeter square. When the set point is too high, then the power supply will indicate that it is drawing too much current with a buzzer tone such as this. I'm using a in-house UV meter to demonstrate the uniformity of the beam. The uniformity is to be calculated by using either a 9 or 6 readings taken at different locations, and then the difference between the maximum and minimum over the sum of maximum and minimum times 100 will give you the uniformity measurement. So usually the uniformity is supposed to be less than 5% of the set value. In order to peak the uniformity, the knobs on the lamp housing access panel behind that, there are 2 knobs to move the lamp to left and right and up and down. So I'm using the center knob up and down and focusing the lamp such a way I get maximum reading. So in order to test the timer, press the expose button to verify the timer operation. Assuming the exposure cycle has ended, raise the microscope and also turn on the max frame up button, turn off the substrate vacuum off and replace the substrate. Now first turn on the substrate vacuum on, and then lower the max frame and press the cycle button to get the microscope into the alignment position. Lower the microscope. Now, observing through the microscope, the patterns can be aligned by moving the Z knob to the left or rotating clockwise to lower the chuck and move the substrate to align the pattern. And then once the alignment is achieved, rotate the knob in such a way that the mask comes in contact with the substrate, and then turn on the contact vacuum and adjust the contact vacuum. A hard contact vacuum is about 20 inches of mercury and a soft contact is about 8 inches of mercury. So depending on the desired contact vacuum, adjust the knob. And to proceed with the exposure, first raise the microscope and then press the cycle button. The UV rays are or injurious, and always use UV protection goggles while doing the lamp alignment or intensity adjustments. And